Hello my dear students. In this video you are going to learn what is domain, what is codomain, and what is range of a function. You will also learn in this video how to find the range and largest domain of a given function. Let us start. So suppose f is a function which are assigned to each x in x a unique element y in y. That is, the function f is from x into y. The set x comprises elements a to e, and in the set y I can see elements 0, 2, 6, and 12. So let us see what is domain, what is codomain. If we have this function f, it says the set x, meaning the first set, is called the domain of the function f, and the set y, meaning the second set, is called the codomain of the function f. So the first set x is the domain, while the second set y is the codomain. If the mapping, or if the function is from x into y, that very first set x is the domain and the second set y is the codomain. But let us see what is range. A range is a subset of the codomain, meaning it's part of the codomain. That range consists of those elements in the codomain that have pre-images. So those elements in the codomain, meaning in the set y with the pre-images, are those elements that makes up the range. Let us see from this drawing. The domain of our function f is a set with the elements a, b, c, d, and e. Simply the set x, the entire of the set x. And the codomain of this our function f, from this drawing you can see, is the set with the elements 0, 2, 6, and 12, meaning the entire set y. So entire set y is the codomain. But for the range we said is a subset of the codomain, meaning it's part of the codomain. It comprises only those elements with pre-images in the domain. So let us see those elements with pre-images in the domain. The elements in the codomain with pre-images are only those elements 0, 2, and 6. 0, 2, and 6 are those only elements that have pre-images in the domain. The element 12 in the set y has no pre-image, so it's not part of the range. Therefore, our range would now be equals to the set with the elements 0, 2, and 6. We take examples. Example number 1, it says let the set x contains the elements minus 2, minus 1, 0, 1, and 2, and let the function g from x into the positive real numbers and is defined by the formula g of x equals to x squared plus 1. The question asked here is to find question A, the domain, question B, the codomain, and the question C, the range of the function g. Solution to this problem, starting with the domain. The domain, remember we said, is the first set. If the function maps from first set to the second set, so that first set is your domain. So domain will now contain those elements in set x. So domain will now consist elements minus 2, minus 1, 0, 1, and 2. Question number B, we asked to find the codomain. The codomain, remember we said, is the second set. If the function maps from first set into the second set, that second set is the codomain. So codomain in this case is the positive real numbers. So we can now say that the codomain is a set contains x such that x is greater than 0. So we continue. We now move to question C. Question C, we asked to find the range. So to find the range, let us get the images of those elements in the domain. That what constitute the members in the range. So let us start with the image of minus 2. Minus 2 is an element in the first set in our domain. So let's get the image of minus 2. So I'll now have g of minus 2. So replacing x by minus 2 in that formula, g of x equals to x squared plus 1. I will now have g of minus 2 to be equals to minus 2 squared plus 1. And minus 2 squared is simply positive 4. So 4 plus 1 gives answer 5. Therefore, the image of minus 2 is 5. I will continue to get all the image of the other elements in the set x. So I'll get g of minus 1. G of minus 1 simply refers to minus 1 squared plus 1. So minus 1 squared is 1. So I add 1 to 1, it will give answer 2. So the image of minus 1 is now 2. I'll continue to get the image of 0. 0 is the next element in my domain. So g of 0 will now be equals to 0 squared plus 1, and 0 squared plus 1 simply give answer 1. Next, I will get the image of 1. 1 is another element, who is the next element in my domain. So g of 1 would now be 1 squared plus 1 and give answer 2. Therefore, the image of 1 is now 2. I'll continue. The last is to find the image of 2. That image of 2 is simply obtained by using this 2 squared plus 1. And 2 squared is 4. Add 4 to 1, it will give answer 5. So those are the images of those elements in my domain. So range, remember, simply we said is a subset of the codomain, but comprising elements that have pre-images. So those elements with pre-images are the members in the range. So my range will simply be a set consisting elements 1, 2, and 5. Another example is says let the function f from real number to real number defined by the formula f of x equals to square root of x plus 4. The question asked here is to find the largest domain and b the range of the function f. Solution to this problem, starting with the question A, that is the largest domain. The domain of this function f are those values that are real numbers that when substituted in the given formula for the function that is square root of x plus 4, the answer will also be another real number, because the function says from real number to real number. So all those values that are real numbers that when substituted in the given formula for the function f of x equals to square root of x plus 4, the answer will also be another real number. So all those set of values will now be in the domain. As we have seen in the formula, we have seen square root. So what our mind will now move to, what we should be thinking about is square root of a negative number. So what we are to get is the likely values of x that when substituted in this formula, the answer will be a square root of a negative number. It is those values that we exclude from the domain. So let me try f of minus 5. If I want to get image of minus 5 is in the domain from the function. Minus 5 is a real number. So if I want to get the image of minus 5, whether it exists or not, let me test and see. So I will now replace the x by minus 5. So I'm going to have square root of minus 5 plus 4. That will be square root of minus 1, and square root of minus 1 is not a real number. So minus 5 doesn't have an image, because square root of minus 1 is not in the codomain. Let me attempt to get the image of minus 6. Minus 6, the f of minus 6 will now be equals to square root of minus 6 plus 4, because I substituted x by minus 6 in the given formula. So I'll have minus 6 plus 4. Square root of that will now be square root of minus 2, and square root of any negative number is not real. The image of minus 6 does not exist. Therefore, this minus 2 is not in the codomain. I can now see the negative values from minus 5 in the domain will not have an image. I now have an idea about my domain. All those values from minus 5, minus 6, minus 7 will not have an image in the codomain. Exclude those values of x that gives negative square root. So my domain would now be a set with x such that x is any number greater or equals to minus 4. This would now be the largest domain I can have for this function. I can now move to question number B that we asked to find the range. The range also, let's get the range. Let me test some values that are in the domain. So let me test f of minus 4. I want to get the likely image. So f of minus 4, I've substituted x by minus 4 in the given formula. So I'm going to have square root of minus 4 plus 4. That minus 4 plus 4 gives me 0, so I have square root of 0. And square root of 0 equals to 0. Let me test f of minus 3. I will now replace the x by minus 3, so I'm going to have square root of minus 3 plus 4. And minus 3 plus 4 gives answer 1, square root of 1 is 1. So if I can continue, maybe f of minus 2, I will still have a real number. F of 1, I will still have a real number. F of 0, I will still have a real number. So my range will now be equals to a set with x such that x is greater or equals to 0. Another example, it says let the function g from r to r, that is from real number to real number, defined by the formula g of x equals to 1 over x minus 3. The question asked here is to find a, the largest domain, and b, the range of the function g. Solution to this problem. So as the formula of this function is an algebraic fraction, what we are targeting is to see that the denominator is 0. What value can replace x so that denominator is 0? That value will remove it from the domain to get the largest domain. Let me get g of 3. G of 3 will now be equals to 1 over 3 minus 3. I have substituted x by 3. And 3 minus 3, the answer will be 0. So I have g of 3 to be equals to 1 over 0. And 1 over 0 does not exist because it's undefined. So the number 3 will not have an image in the codomain, which means 3 should not be a member in the domain. So my domain will now be equals to x such that minus infinity is less or equals to x and x is less or equals to infinity. Simply this means a number from minus infinity to infinity, but excluding 3. This would now be the largest domain. The largest domain of this function would now be any real number exception of 3. I will move to question number B, which we are asked to find the range. The range of this function also, I will check the formula for the given function g of x equals to 1 over x minus 3 and think what are the likely answers I will have as an image of elements in the domain. Any value that you think that when substituted in this formula 1 over x minus 3, the answer would never be 0. Even if x is 0, the answer would be 1 over minus 3. Whatever x is, provided is not 3, the answer would not be 0. So the range will now be equals to the set containing x such that minus infinity is less or equals to x, and x is less or equals to infinity, but with the exception of 0. Another example 4, it says let the function h from r to r, meaning from real number to real number, and is defined by the formula h of x equals to 3x squared minus 7x plus 4 all over x squared plus 2x minus 3. The question asked here is to find the largest domain of the function h. Solution to this. What we simply do also in this case, we can see in the formula of the given function, it is an algebraic fraction. So what we are targeting to get is to check what are the likely values of x that the denominator will be 0. So we now take our denominator, that expression, what value of x that makes it to 0 is what we exclude from the set of real numbers. So if I should solve that quadratic equation at the denominator, if I should solve it equals to 0, the answers that I will get, the roots of that quadratic equation, is those roots that I will exclude from the domain, because those will make the denominator 0. So solving x squared plus 2x minus 3, that is my denominator. I will now solve it by factorization method. So I'm going to have x plus 3 into x minus 1. So solving this equation, I will now have x plus 3 into x minus 1 equals to 0. This result, the roots will now be x equals to minus 3 or x equals to 1. So the domain of this function h will now be any real number with the exception of minus 3 and 1. So domain will now be equals to set contain x such that minus infinity is less or equals to x, and x is less or equals to infinity, but x cannot be minus 3 and also x cannot be 1. These are the only two values we removed from set of real numbers to get the largest domain. This is the end of this lesson, so let us revise some of the things that we have learned in this lesson. In this lesson, you have learned that if f is a function from x into y, the domain of that function is the set x, meaning the first set, and the codomain of that function is the set y, meaning the second set. You have learned in this lesson that range is a subset of the codomain. It consists precisely all the elements of the codomain which appears as the image of at least one of the elements in the domain. That is, in short, the subset of the codomain containing elements that have free images in the domain is your range. You have also learned in this lesson that the largest domain of a function is the set of all real numbers for which the expression is defined as real, meaning the formula for the given function is defined as real. All those values that can give another real number when substituted in the given formula for the function, that sort of values will now be your largest domain.